Imagine standing beneath a star-filled sky, each pinprick of light a story of creation, chaos, and inevitable decline. Now ask yourself, how much of the universe is already dead? It's a question that feels almost too vast to grasp, like trying to hold the cosmos in your hands. Yet it's a question that has haunted humanity's greatest minds, from ancient stargazers to modern astrophysicists. The universe, with its shimmering galaxies and blazing stars, seems eternal, a frozen snapshot of infinity. But beneath this illusion of permanence lies a truth both beautiful and heartbreaking. The cosmos is changing, and much of it has already begun its long descent into darkness. This is not just a tale of science, but a saga of birth, life, and death, on a scale that dwarfs imagination. It's a story that began billions of years ago in a crucible of light and will end in a whisper of cold emptiness. Along the way, we'll uncover the brilliance of a forgotten Swedish physicist who dared to simulate the universe in a darkened gymnasium, witness the fiery birth of galaxies, and confront the silent forces that are already snuffing out the stars. This is the story of the universe's twilight, and it's a tale that demands to be told. So grab a seat, let your curiosity guide you, and let's journey through the cosmos together. Don't forget to share your thoughts in the comments below. What does the fate of the universe mean to you? In 1940, in a shadowed gymnasium in Stockholm, a Swedish physicist named Erik Holberg embarked on an experiment that would change how we see the universe. Largely forgotten today, even among astrophysicists, Holberg was a pioneer who dared to ask what the cosmos was truly made of. His idea was audacious, yet elegantly simple: to recreate the dance of galaxies using nothing more than light bulbs and photoreceptors. In that dimly lit room, he and his students meticulously arranged 74 stations, each equipped with a bright bulb to represent the gravitational pull of a galaxy's mass and a receptor to measure the light received. These stations were not mere props. They were proxies for the swirling spiral galaxies on the brink of a cosmic merger. Holberg's setup was the world's first analog computer simulation of the universe. He divided the stations into two groups, sketching the rough outlines of two galaxies poised to collide. Then, with painstaking precision, he set the lamps in motion. By measuring the light at each station, he calculated where each galaxy should move, as if time had fast-forwarded a million years. Again and again, he repeated this process, watching as the galaxies stretched, twisted, and merged, their tidal tails arching gracefully across the gymnasium floor. It was a mesmerizing ballet of light and shadow, a glimpse into the exquisite beauty of cosmic evolution. But beauty was not all Holberg saw. Amid the glowing bulbs, he witnessed something profound: the death of galaxies. He saw how the universe, far from being static, was a place of relentless change. The vibrant galaxies we cherish, strung like jewels across the cosmic web, are not eternal. Holberg's experiment revealed a truth that would echo through decades of research. The universe has a lifespan, and parts of it are already fading. As you read this, take a moment to imagine standing in that gymnasium, watching the cosmos unfold. What would it feel like to see millions of years pass in a single night? Share your thoughts below, and let's keep this cosmic conversation going. Long before Holberg's gymnasium glowed with artificial stars, the universe itself was a place of unimaginable chaos. Picture a time 13.8 billion years ago, just after the Big Bang, when the cosmos was a seething cauldron of energy. There were no stars, no galaxies, no planets, only a dense, hot plasma where matter and light were indistinguishable. Within minutes, this primal soup cooled just enough to condense into the first elements: hydrogen, helium, and trace amounts of lithium. These were the building blocks of everything to come, forged in a fleeting moment that would never repeat. Fast forward 380,000 years, and the universe underwent a transformation so dramatic it left an indelible mark: the cosmic microwave background, CMB. As the universe cooled, the plasma gave way to neutral gas, releasing a flood of radiation that we can still detect today as a faint whisper of the Big Bang. This was a one-time event, a cosmic milestone that will never happen again. The CMB is our window into that primordial era, but it's fading, stretched thin by the universe's expansion. Soon, it will be too faint to observe, a relic lost to time. Then came the Dark Ages, a time before stars, when the universe was a cold, dark void. But gravity, the silent architect of the cosmos, was at work. Diffuse clouds of gas began to clump together, their mutual attraction igniting the first sparks of fusion. Somewhere, in an unknown corner of the vast cosmos, the first star blazed to life, shattering the darkness with its light. These were no ordinary stars, but supermassive giants, unlike anything we see today. They burned fiercely and died quickly, seeding the universe with heavier elements, carbon, oxygen, iron, that would form the dust and gas needed for future stars and planets. This was the cosmic dawn, a time of frenetic creation when the first galaxies formed. These early galaxies were small, chaotic, and ravenous, feeding on surrounding gas to birth stars at a staggering rate. The James Webb Space Telescope, JWST, launched in 2021 and still delivering breathtaking data as of September 4th, 2025, has shown us these infant galaxies. One, known as Z14, formed just 282 million years after the Big Bang, its young stars blazing with the promise of growth. These galaxies were the seeds of the cosmic web, a vast lattice of filaments, walls, and voids that defines the universe's structure today. Can you picture this vibrant, youthful cosmos? What would it be like to witness the birth of the first stars? Drop a comment and let's explore this together. By 3 to 3.5 billion years after the Big Bang, the universe reached its zenith, a period astronomers call cosmic noon. This was the golden age of star formation, a time when galaxies churned out stars at a rate 10 times higher than today. Imagine a night sky so dense with stars that it rivaled daylight, each one a testament to the universe's youthful vigor. The Atacama Large Millimeter / Submillimeter Array, ALMA, perched 5,000 meters above Chile's bone-dry desert, has given us a front row seat to this era. In 2015, astronomer Hideki Umehata used ALMA to map the SSA-22 protocluster, a colossal nursery of galaxies 12 billion light-years away. Spanning 200 million light-years, this protocluster was a cosmic metropolis in the making, its galaxies feasting on filamentary gas to fuel their star-forming frenzy. During cosmic noon, galaxies were not the serene spirals we know today. They were turbulent, battling for resources in a universe far smaller and denser than ours. The Hubble Space Telescope's Candle survey, conducted between 2010 and 2013, captured this drama, imaging over 250,000 galaxies and revealing a cosmos where galaxies collided, merged, and cannibalized each other. These encounters sparked bursts of star formation, sometimes at rates 1,000 times greater than the Milky Way's modest 7 stars per year. Our own galaxy bears the scars of this violent past, with remnants like the Sagittarius Stream and the Gaia Sausage. Shredded galaxies absorbed into the Milky Way's embrace. Dust, that humble cosmic ingredient, played a starring role in this drama. Formed from the ashes of dead stars, dust cooled gas clouds, allowing them to collapse into stars. ALMA's observations reveal a universe thick with dust, shrouding young galaxies in hazy veils. But this frenzy couldn't last. Cosmic noon was a fleeting peak, a moment when the universe burned brightest before beginning its slow decline. As you imagine this era of cosmic excess, what strikes you most about the universe's youthful chaos? Share your thoughts in the comments, and let's keep the conversation alive. Today, on September 4th, 2025, we live in the cosmic evening, a time when the universe's star-forming fires have dimmed. The Milky Way, once a hotbed of activity, now produces just a handful of stars each year. Across the cosmos, galaxies are quieter, their once vibrant nurseries reduced to sleepy backwaters. The JWST's deep surveys confirm this shift, showing that modern galaxies are larger and more structured, but far less prolific. The cosmic web, now fully formed, is a testament to the universe's evolution, but it's also a harbinger of decline. What caused this cosmic slowdown? The answer lies in the very forces that fueled the universe's rise. Galaxies, it seems, are victims of their own success. Astronomers use the term quenching to describe the processes that snuff out star formation, turning vibrant galaxies into red and dead husks. One culprit is intense star formation itself. Massive stars born in clusters unleash stellar winds and supernova explosions that heat and expel gas, preventing it from collapsing into new stars. The local bubble, a 1,000 light-year wide void around our solar system, is a relic of such explosions carved out by supernova millions of years ago. Galactic mergers, once drivers of star formation, can also spell doom. When galaxies collide, their gas is compressed, sparking starbursts but also heating and dispersing the material needed for future stars. The illustrious TNG simulation, a modern successor to Holberg's physics gymnasium experiment uses 100,000 computer cores to model these processes, revealing how galaxies grow and die. Another killer lurks at the heart of nearly every galaxy, the supermassive black hole. In galaxies like M87, a leviathan with trillions of stars, these black holes power quasars, blazing beacons that outshine entire galaxies. When active, quasars emit radiation and jets that heat and eject gas, starving galaxies of star-forming fuel. But the story of galactic death is not just one of internal betrayal, it's also shaped by the environment. As galaxies drift through the intergalactic medium, they encounter hot plasma within galaxy clusters. This plasma, though thin, can strip away a galaxy's gas through friction, creating jellyfish galaxies with streaming tentacles of gas trailing behind them. These galaxies, observed in real time by telescopes like ALMA, are caught in the act of losing their star-forming potential, their vibrant blues fading to dull reds. The universe's expansion further exacerbates this decline, stretching the distances between galaxies and reducing the flow of fresh gas. Imagine a galaxy as a bustling city slowly abandoned, its lights dimming one by one. How does this image of cosmic decline resonate with you? Share your reflections in the comments below. The universe's decline is not just a matter of fading stars, it's driven by a force we barely understand: dark energy. Discovered in 1998, dark energy accelerates the universe's expansion, pulling galaxies apart and starving them of the gas needed to form stars. As of September 4th, 2025, observations from the JWST and other telescopes confirm that dark energy has dominated for over 5 billion years, sealing the cosmos's fate. If this acceleration continues, the universe will grow ever colder and emptier, its galaxies dissolving into isolation. In 100 billion years, the observable universe will vanish. Galaxies beyond our local group, comprising the Milky Way, Andromeda, and their satellites, will be carried away by dark energy, receding faster than light until they disappear. The cosmic microwave background, already faint, will become undetectable, its red-shifted whispers lost to the void. The Milky Way itself will merge with Andromeda to form Milkomeda, a new galaxy that will slowly unravel as stars and planets are ejected by gravitational encounters. By 1 trillion years, the universe will be a shadow of its former self. Red dwarfs, the longest-lived stars, will evolve into blue dwarfs, glowing faintly like cosmic embers. By 10 to 100 trillion years, the last conventional stars will form, sparked by rare collisions of brown dwarfs. After that, the galaxy will dissolve entirely, its stars flung into the abyss. By 10 to the 15th power years, our sun, now a black dwarf, will cool to near absolute zero. Planets will drift alone, untethered from their stars. And in 10 to the 100 years, even black holes will evaporate via Hawking radiation, leaving nothing but a sparse sea of particles. Yet, even in this desolate future, the universe may hold surprises. In 1 trillion years, as the cosmos grows richer in heavy metals, stars could form at lower masses and temperatures than ever before. Some may be so cool that their surfaces are encased in ice, glowing faintly as frozen stars. These ghostly lights, barely detectable, will be the last embers of a dying cosmos, persisting in a universe that has grown unimaginably vast. Picture a solitary frozen star, adrift in an endless void. What stories might it tell? Drop a comment with your thoughts on this eerie vision of the future. In this distant future, a strange new phenomenon may emerge. Iron stars. Formed through cold fusion mediated by muons, these solid spheres of iron will persist for eons, glowing faintly above absolute zero. But even they will succumb to quantum tunneling, dissolving into nothingness by 10 to the power of 10 to the power of 76 years. The universe will end as a cold, empty void, a far cry from the fiery chaos of its youth. What does this vision of cosmic oblivion make you feel? Share your thoughts in the comments, and let's grapple with the universe's ultimate fate together. As we stand in the cosmic evening, gazing at a sky that grows quieter with each passing millennium, we're confronted with a paradox. The universe's impermanence is what makes it so extraordinary. Every galaxy, every star, every fleeting burst of light is a moment in a grand narrative that spans billions of years. The same forces that birthed the stars, gravity, fusion, cosmic collisions, are now conspiring to extinguish them. Yet, in this slow fade, there's a profound beauty, a reminder that even the mightiest biggest structures in the cosmos are transient. The galaxies we see today, including our own Milky Way, are but temporary sculptures, shaped by the hands of time and destined to dissolve. This cosmic story also invites us to reflect on our place within it. The elements that form our bodies, carbon, oxygen, nitrogen, were forged in the hearts of ancient stars, scattered across the universe in their fiery deaths. We are, in a very real sense, children of the cosmos, carrying its history within us. As the universe drifts toward darkness, our ability to observe and understand it is a fleeting gift. Telescopes like the JWST, still capturing stunning images in 2025, allow us to peer back to the universe's youth, but even these tools will one day fall silent. What does it mean to be a witness to this cosmic drama, knowing our time to observe it is so brief? Share your thoughts below and let's explore the human connection to the stars. The universe's twilight is not just a scientific fact, but a call to wonder and action. It urges us to look up, to question, to explore, and to share our awe with others. The story of the cosmos is a collective one, and your voice matters. Whether you're moved by the fiery chaos of cosmic noon, or haunted by the silence of iron stars, let this tale inspire you to engage with the universe's mysteries. Leave a comment with your reflections, give a thumbs up to spread this story, or subscribe for more journeys through the cosmos. Together, we can keep the spark of curiosity alive, even as the stars themselves fade. What's one question about the universe you'd love to explore next? Let's discuss it below. Let's journey back to the era of cosmic noon, that fleeting epoch when the universe pulsed with unparalleled vitality. Picture a cosmos teeming with activity, where galaxies were not just forming, but thriving in a frenetic dance of creation. The skies of that time, some 10 billion years ago, would have been a spectacle beyond comprehension. A tapestry woven with tens of thousands of stars, each a blazing furnace forging new elements. The James Webb Space Telescope, as of its latest observations in September 2025, has revealed galaxies from this era that are smaller and dimmer than today's grand spirals, yet bursting with star-forming regions. These galaxies, like cosmic adolescents, were wild and untamed, their gravitational embraces pulling in vast clouds of gas to fuel their stellar nurseries. The SSA-22 protocluster, observed by ALMA, stands as a monument to this era, a sprawling complex where galaxies collided and merged, their interactions sparking starbursts that lit up the cosmos like fireworks in an endless night. This was a time when the universe was not just alive but exuberant, a place where creation seemed unstoppable. Yet, even in this golden age, the seeds of decline were sown. The very processes that birthed stars, collisions, mergers, and the accumulation of dust set the stage for their eventual quenching. As you imagine standing on a planet in this vibrant era, looking up at a sky ablaze with stars, what emotions does it evoke? Share your thoughts in the comments, and let's revel in the universe's youthful glory together. The decline of the universe is not a sudden catastrophe, but a slow, insidious process driven by forces both within and beyond the galaxies themselves. Consider the role of supermassive black holes, those enigmatic titans lurking at the hearts of galaxies like M87. These cosmic behemoths, some with masses millions or billions of times that of our sun, are both creators and destroyers. In their youth, they power quasars, blazing engines of light that can outshine entire galaxies. The Event Horizon Telescope's 2019 image of M87's black hole, still a landmark in astronomy as of 2025, revealed a shadow surrounded by a glowing accretion disk, a testament to its ferocious appetite. When a galaxy undergoes a major merger, the influx of gas can awaken these black holes, triggering jets of particles that travel thousands of light years, scouring the galaxy of its star-forming material. These jets, guided by magnetic fields, act like cosmic blowtorches, heating and expelling gas until the galaxy is left barren. But black holes are not the only culprits. The intergalactic medium, a thin plasma threading through galaxy clusters, plays a sinister role. As galaxies move through this medium, they experience ram pressure, a cosmic wind that strips away their gas, leaving behind the hauntingly beautiful jellyfish galaxies with their trailing tentacles. Observations from ALMA and other telescopes in 2025 show these galaxies in their death throes, their vibrant blues fading to the dull reds of extinction. This slow strangulation, combined with the universe's relentless expansion, ensures that even the most resilient galaxies will eventually succumb. How does the idea of these silent killers reshaping the cosmos make you feel? Drop a comment below to share your perspective. As we peer into the far future, the universe's fate becomes a story of solitude and silence. In 100 billion years, the accelerating expansion driven by dark energy will have reshaped the cosmos into a vast, empty expanse. Galaxies outside our local group will vanish beyond the cosmic horizon, their light unable to reach us as they recede faster than the speed of light. The Milky Way and Andromeda will merge into Milkomeda, a single galaxy that will dominate our observable universe. But even this grand structure will not endure. By 1 trillion years, gravitational interactions will scatter its stars, sending them drifting into the void. The cosmic microwave background, that faint echo of the Big Bang, will have redshifted into oblivion, leaving no trace of the universe's fiery birth. In this era, new types of stars may emerge, blue dwarfs and frozen stars, glowing faintly in a cosmos grown cold and sparse. By 10 to the 15th power years, our sun, now a black dwarf, will be a mere 5 degrees above absolute zero, a lonely relic adrift in an empty galaxy. Eventually, even these remnants will fade as black holes evaporate and matter itself dissolves through quantum processes. In 10 to the power of 76 years, the iron stars, those strange cold spheres of pure iron, will succumb to quantum tunneling, leaving a universe of subatomic particles separated by unimaginable distances. This vision of a solitary cosmos, where even the last vestiges of structure vanish, is both haunting and humbling. It reminds us that our moment in the universe is fleeting, a brief chance to witness its wonders. What does this image of a lonely universe inspire in you? Share your reflections in the comments, and let's ponder the cosmos's ultimate solitude together. The cosmic web, that intricate lattice of filaments, walls, and voids that defines the universe's large-scale structure, is both a triumph of cosmic evolution and a testament to its fragility. As observed through the JWST's Deep Field images in September 2025, this web began as a diffuse network of gas in the early universe, gradually sculpted by gravity into the majestic framework we see today. During cosmic noon, galaxies clustered at the nodes of these filaments, drawing sustenance from vast reservoirs of gas that flowed like rivers through the cosmos. These filaments, stretching millions of light years, were the lifelines of galaxies, feeding their star-forming engines and enabling the frenetic creation of cosmic noon. But as the universe expanded, these threads began to thin. Dark energy, accelerating the cosmos's growth since its discovery in 1998, has stretched the distances between galaxies, weakening the flow of gas along these cosmic highways. Today, the cosmic web is still vibrant, with galaxies like our Milky Way nestled in its embrace, but its vitality is waning. Simulations like illustrious TNG reveal that the web's structure will continue to evolve, its filaments fraying as galaxies drift apart. In billions of years, the web will become a ghostly relic, its threads stretched so thin that they can no longer sustain star formation. This slow unraveling of the cosmic web is a poignant reminder of the universe's impermanence, a once vibrant network fading into obscurity. Imagine the cosmic web as a tapestry woven by gravity, now slowly unraveling. What does this image evoke for you? Share your thoughts in the comments, and let's explore the delicate balance of the cosmos together. The story of the universe is not just a tale of stars and galaxies, but also a chronicle of human curiosity and ingenuity. From Eric Holberg's gymnasium experiment in 1940 to the cutting-edge telescopes of 2025, our quest to understand the cosmos has been a journey of relentless exploration. The James Webb Space Telescope, ALMA, and the Event Horizon Telescope represent the pinnacle of human achievement, allowing us to peer billions of years into the past and witness the universe's youth. These tools have revealed the chaotic beauty of cosmic dawn, the exuberance of cosmic noon, and the quiet decline of cosmic evening. But they also highlight the limits of our reach. As the universe expands and dark energy drives galaxies beyond our sight, our ability to observe the cosmos will diminish. In 100 billion years, the observable universe will shrink to our local group, and future astronomers, if they exist, will see only a fraction of the wonders we can still behold. This fleeting window of observation underscores the urgency of our quest. Every discovery, from the cosmic microwave background to the shadow of M87's black hole, is a triumph of human intellect, a testament to our drive to unravel the mysteries of existence. Yet, it's also a humbling reminder of our smallness in the grand cosmic narrative. As we stand on the cusp of cosmic twilight, what inspires you most about humanity's pursuit of cosmic knowledge? Drop a comment below, and let's celebrate the human spirit that dares to explore the stars. The universe's story is one of breathtaking creation and inevitable decay, a narrative written in starlight and shadow. From Eric Holberg's Gymnasium to the cutting-edge simulations of 2025, we've learned that the cosmos is not a static painting, but a living, breathing entity with a finite lifespan. We stand in its twilight, surrounded by galaxies that are already fading, their stories preserved in the light that reaches us across billions of years. Yet this tale is not one of despair. The universe's impermanence is what makes it so precious. Every star, every galaxy, every fleeting moment of cosmic noon is a testament to the beauty of change. As we gaze at the night sky, we're not just seeing stars, but witnessing history. A history we're part of. The same elements forged in those ancient stars course through our veins, connecting us to the cosmos in ways both profound and humbling. So what can we do with this knowledge? Let it inspire you. Look up at the stars and marvel at their stories. Share this journey with others. Leave a comment below with your thoughts on the universe's fate, or spark a discussion with friends. If this tale has moved you, give it a thumbs up to spread the wonder, and subscribe for more cosmic adventures. The universe may be fading, but our curiosity can burn bright. Let's keep exploring, questioning, and celebrating the cosmos together. What's the one thing about the universe that captivates you most? Let's talk about it below.